this is task 2 for Algebra 1. Just as a reminder, you can find the notes in my Algebra 1 folder on my School Loop locker. I'm going to go fairly fast through these. There is a reference to your notes, to your textbook. Page 26, I do want you to go, in fact now would be a really good time, go ahead and hit pause and go review the words associated with the symbols equals and all the inequality symbols. And the reason I want you to look at them is sometimes they're a little bit counterintuitive. So I'm going to go ahead and go through these examples right now. Basically, equalities and inequalities are sentences that relate to expressions, and expressions are what we've been looking at, using these symbols, equals or an inequality sign. When you write an equation or an inequality, you need to be very, very careful about the language because, well, let's see. This first one isn't so bad. It's pretty straightforward. The product of 8, and a number x, well, that's just 8x, is, when it's all by itself, generally means equals 15. 8x equals 15. The product of x and a number is 15. Okay, now here's where it gets a little trickier. The sum of 3 times the number m and 7. So we know we have a plus. 3 times the number m, that's 3m, and 7, is at least. Now, that least word means sometimes people want to put less than. Is at least 25. That means it's 25 or more than 25. So it's greater than or equal to 25. Okay, now you try, which means I want you to pause, hit pause, and try it, and then come back and check your answer. Alright, so the difference of 12 and a number h, and generally subtraction goes sequentially, although that's not always the case. You do have to be careful, but it's generally written the way you read it. The difference of 12 and a number h is 12 minus h is no more than 3. Don't get tripped up by the words more than. It's not more than 3. So here's our 3, and we want to put less than or equal to. It's less than 3 if it's not more than 3, and if it's no more than 3, it certainly can be equal to 3. So it's less than or equal to. Okay, now let's look at substitution. Now here, this part of the reason I want you to see this is it's a really good way to check your work. Once you've solved an equation, you can go back and substitute in the value you got for your variable and just double check your solution. So this is just a good skill to have. We're going to check whether 4 is a solution for the inequality or equation. So all you have to do is substitute in 4. And here we get 12 over 2 equals 6. 6, that's a solution. So we're good. You can put yes also on your test. That would be fine. Okay, let's substitute 4 in here. So 8 minus 7 is greater than or equal to 6. 1 is greater than or equal to 6. Is that true? It's not true, and when it's not true, it is not a solution. We need to see whether the value makes the statement true, and in this case it does not. Okay, you go ahead and hit pause and give this one a try. So we're checking 6 plus 4 is less than 15. 10 is indeed less than 15, so it is a solution. All right, now mental math. This is where we begin to look at solving equations and some of the approaches we can take. And one quick little trick you can use is to substitute the variable with the word what. So what plus 7 equals 12? What plus 7 is 12? Well, the answer would be 5. And then you can check your solution. This seems fairly simple, but it's a really good habit to get into. 12 is 12. I'm sorry, being left-handed, you're spending a lot of time looking at my hand, and that's unfortunate, but I'll do my best to write quickly. Okay, 8 times what is 32? 8 times what is 32? Well, 8 times 4 is 32. And then you can write your check. 8 times 4 equals 32. Yes, indeed. And again, this seems silly, but it's just a good habit. Here's the you try. Go ahead and hit pause and give it a try. Now what we were doing is substituting the word what for the variable. So what divided by 6 is 5. Well, that would be 30. So 30 over 6 equals 5. Okay, word problems. So take a look at the problem, and the first thing you're going to do, these are very good steps for solving problems. The only other thing I'd add in here is that sometimes it helps to draw a picture. I'm not sure how much it helps in this case, but I frequently draw a picture, and if drawing a picture of a backpack and some little water bottles helps you, please do. So you're hiking, and the total weight of your backpack and its contents is 13 3/8 pounds. You want to carry no more than 15 pounds. So we know already that the amount of weight we have available to us is 15 minus 13 3/8. That's what's left in the backpack. How many extra water bottles can you add to your pack if each bottle weighs 3/4 pound? Well, let's make a plan, and what would be a good variable? I often look at what the question is, how many extra water bottles? Oh, let's let W equal the number of water bottles. Okay, so if W is the number of water bottles, and we know how much weight we have left, we need to find out the weight of W, a given number of water bottles. And that would be 3/4 pound times W. That would be the weight. Now, how can we compare this to that? Do they have to be equal? Not necessarily. The weight of the water bottles just has to be less than or equal to the weight available. Less than or equal to. So that is our inequality. So now we can solve the problem, and I'll just point up here. So 3/4 W is less than or equal to 1 5/8. Let's make this into an improper fraction. 3/4 W is less than or equal to 13 over 8. Remember, 1 times 8 plus 5, this is how you turn it into an improper fraction. Now we can multiply both sides by the reciprocal. And that leaves us with W is less than or equal to, well, the 8 and the 4 cancel. So we get 2 and 1, and this gives us 13 over 6. Well, 13 over 6 is the same thing as 2 and 1/6, because 6 goes into 13 twice with 1 left over. So we have less than or equal to 2 and 1/6 water bottles. Now, the reason I included this problem is I think I want you to think through that. This is a really good example of thinking about what exactly the numbers we're using mean. This is the number of water bottles. So how many water bottles could we have? Could we have 3? No, but we could have 2. I'm assuming we can only have whole water bottles. So you could have 2 water bottles. Now, checking for reasonableness, you could go ahead and plug this 2 back into the equation and see if it works. But when you're checking for reasonableness, you're just eyeballing it to see if it makes sense. Does this answer make sense? And yes, it makes sense that you could add 2 3/4 pound water bottles when you have a little over a pound left. Now, or almost 2 pounds left in your pack. Now, if you had gotten an answer of 20, you might go back and say, wait a second, it's time to go back and check my numbers. Now, using formulas to solve word problems. There are a couple of ways you'll see word problems with formulas. One is where they expect you to know a formula. It's pretty basic, like the area of a rectangle or the perimeter of a square. In other cases, they'll give you a formula and you have to figure out what to plug into the formula. And we'll see a lot of examples of those. In this case, we're going to use a formula that we already know. We know the area of a rectangle. If we have a rectangle with length L and width W, then the area equals length times width. L equals length and W equals width. Okay, if we want to know the perimeter of the rectangle, that's the distance around or the sum of the sides. Well, two of the sides are L, length L, and two of the sides are length W. So it's 2L plus 2W, where L equals length and W equals width. Now what about a square? If we have a square with side length S, side length, then the perimeter is the sum of the sides. That would equal 4S. So those are some examples of formulas. Let's see which one we're going to use in this word problem. A builder lays sod. Sod is just pieces of lawn that you roll out. You've probably seen it at Home Depot or your local garden store. The installed cost of sod is 38 cents per square foot. So I'm guessing we're going to be looking for a measure in square feet. What's the cost of installing sod in a rectangular lawn? That helps that the lawn is rectangular. That's 32 feet long and 18 feet wide. Well, first we're going to need to know the area in square feet. And the area would be the length times the width. The length is 32 and the width is 18. So the area is 32 times 18. And that happens to be 576. You can check it by doing multiplication on your paper or using a calculator. Okay, so 576 square feet. Now, we're paying 38 cents per square foot. So for every one of these square feet, we have to dole out 38 cents. So that's a multiplication problem. So it's 576 times 0.38. And that ends up being, I went ahead and did it before, 218.88. Please check my math.